Okay. So we will discuss. We already discussed this, but again we will revise it once. Okay. Forward vising means this is your diode, PN junction diode. This is P side. This side is N side. This straight line is representing N side, and this triangle is representing P side. So this is PN junction diode, and this is a battery. This is a battery. So, and this is the rheostat. With the help of the rheostat, you can change the potential difference here. So now, hmm, so now you can see here the positive end of the battery when connected to the P side, negative end of the battery is connected to the N side. Then this is a forward wise condition of this diode. Forward wise condition of this diode. In this case, I told you the potential barrier will decrease. Potential barrier will become V minus VV. It will decrease. So potential barrier will decrease. The current will increase. The current will increase. Okay. Current will increase. In case of the reverse biasing, we discussed that when the negative end of the battery is connected to the P side, and when positive end of the battery is connected to the N side of the PN junction, then this PN junction is said to be reverse biased. In reverse bias, the potential barrier increases and current decreases. Okay. So now we will discuss the characteristics of the reverse bias and the forward bias. Characteristics. Characteristic means we will draw the current versus voltage graph in case of the reverse bias and in case of the forward bias. So first we will discuss the characteristics in case of the forward bias. So VI characteristics in forward bias. Uh, this is the PN junction diode. This is the PN junction diode. Okay, and this PN junction diode is in the forward bias condition. Positive end is connected to P side, negative end is connected to N side. Now, in parallel to this junction diode, a voltmeter is connected, and in series of this diode, a milliammeter or ammeter is connected. Voltmeter is used to measure the potential difference, and voltmeter is always connected in parallel. Ammeter is used to measure the current, and ammeter is always connected in series. So this is the milliampere because the current will be in milliampere we discussed. After that, this is a forward biasing condition, so potential barrier will decrease. Potential barrier will decrease. Okay. So we will see when we will increase this voltage in the forward direction, or when we will increase this voltage, the potential barrier will reduce. The potential barrier will reduce. Okay. The potential barrier will reduce means there will be the flow of majority charge carrier will increase, and depletion layer thickness will decrease, and the resistance for the majority charge carrier will decrease and the current will increase when you will increase the potential difference. Initially, when you will increase the potential difference B, current will slowly increase. When this value becomes equal to this value, then applied voltage becomes equal to the barrier voltage, then suddenly the current will increase. After that, when you will change little applied voltage. So this type of graph you are going to get. This type of graph. So this VF, V suffix F is this is I suffix F. This is in milliampere. Okay. So now from here to here, from A to B, suppose from here to here means from this point to this point, from this point to this point. you are increasing the applied voltage. You are increasing the applied voltage. Net voltage is decreasing. Net voltage is decreasing. So net voltage is decreasing. So current is increasing little bit. Okay. Suppose you reached here. From here to here, again you increase the applied voltage. Again, the potential barrier will decrease. Suppose you have applied the voltage that is equal to the knee voltage. That is equal to the knee voltage. So this knee voltage, when you will reach at the knee voltage, when you will reach at the knee voltage, then this voltage will become equal to this voltage. Means net voltage will become barrier potential will become zero, and current will suddenly increase. Basically, this is, we cannot say this is a net voltage. Current will suddenly increase from here because the barrier voltage will become zero. So this is the theory. Initially, the current in the circuit is negligible till the voltage reaches knee value or cut-in voltage, and the knee voltage for silicon is 0.7 electron volt. For germanium, it is 0.3 electron volt. Before cut-in voltage, the depletion layer plays a dominate role in providing barrier to the majority charge carrier. Basically, they are saying that when the voltage is less than the knee voltage, current is very, very less. We know that in the graph you can see. Before the knee voltage, the current value is less. This is why, because at that time the depletion layer thickness is large. There is a significant there is a large depletion layer thickness or length of depletion layer, and after that they are saying, so if depletion layer is thickness is more, then what will happen? Less charge carrier will flow. There will be less flow of the charge carrier. Okay. Now on reaching the knee voltage, the current increases exponentially. Even for a very small change in applied voltage at this stage, for the majority charge carrier, there will be negligible resistance at junction. There will be negligible resistance at junction. So when you will reach at the knee voltage, potential barrier will remove, potential barrier will become zero, and after that, but you will increase the current means increase a very small amount of current, then very small amount of voltage. After this voltage, when you will increase a small amount of voltage, then the current will increase sharply. Okay, so this is the condition for the reverse forward biasing. So this is what I have written. Okay, so characteristics for reverse forward biasing. Now we will discuss the characteristics for the reverse biasing. So in case of the reverse biasing, this is the PN junction. This PN junction is reverse biased. Negative end of the battery is connected to the P side. Positive end of the battery is connected to the N side. Voltmeter is connected in parallel, and a microammeter is connected in series. Why we are connecting here a microammeter? Because in reverse bias the current is very, very less. So in this case the potential barrier will increase, and okay. So potential barrier will increase. So what we have to do? We will increase this applied voltage in the negative direction. So we have to plot the graph in third quadrant. So in the negative, this is the negative direction. In this direction, we are applying the voltage, increasing the applied voltage, and initially the current value will be saturated value, means a constant value. This is known as the reverse saturation current. Okay. After reaching this voltage, at this voltage or after reaching this voltage, the current will increase sharply. Okay, current will increase sharply. Is this current is reverse saturation current. IR is the current in reverse biasing. VR is the applied voltage, negative applied voltage. You can say reverse applied voltage, reverse applied voltage. Okay, so this is very easy. So when diode is connected in reverse bias, the current remains almost constant with biasing, and this current is called reverse saturation current. And it is due to the flow of thermally generated minority charge carriers, holes in p-type and electrons in n-type across the junction. So this reverse saturation current is due to the minority charge carrier, and this is a constant current. When a reverse voltage reaches a sufficiently high value, the current increases rapidly, and this voltage is known as the Zener breakdown voltage. So when the reverse voltage increases to this value, here the current suddenly increases, and this value of voltage is known as Zener breakdown voltage. Zener breakdown voltage. As the value of this voltage is 1 to 2 volt to several thousand volt, it depends upon the doping concentration. So this breakdown voltage will depend upon the doping concentration of PN junction. Okay. After this, we have rectifier. Basically, rectifier is a device used to convert the alternating current to the direct current. Means alternating current to the direct current. So this is a rectifier. This rectifier will convert the alternating current to direct current. Two types of rectifier are there: half wave rectifier, full wave rectifier. Now first we will discuss the principle of the rectifier. For ideal diode, for ideal diode, for ideal diode, the diode will conducting. We will consider the ideal diode. Diode means if the diode is in the reverse bias, it will not conduct. If the diode is in forward bias, it will conduct then. The diode will conduct during forward biasing and it will not conduct during reverse biasing. Now we will discuss the half wave rectifier. Half wave rectifier. This is very easy. So basically, this is a figure of the half wave rectifier. This is the primary winding. This is the secondary winding. Okay, this is the primary. This is the primary winding. This is the secondary winding. Okay, and this primary winding is supplied with AC supply. Okay, here is a AC source connected. Okay, so two windings are there. Mutual induction will take place. So the voltage here can be represented like this. Okay, positive half cycle, negative half cycle, positive half cycle. So during positive half cycle, suppose this A is positive. If this A will be positive, means positive is connected to P side and this B will be negative. So negative is connected to the N side. So this diode is in the forward bias condition. So it will conduct, means current will flow through it. So current will flow through it and current will flow through the load. And when the current will flow through the load, we will get the output. But now, after that, during this negative half cycle, this A is negative, suppose, and B is positive. So in this case, what will happen? Negative is connected to P side, positive is connected to N side, reverse bias. This diode will be reverse bias. And in reverse bias condition, this diode will not conduct, mean no current will flow through the load and we will not get any output. Simple, finish. Working during positive half cycle, A is positive and the end B is negative and diode is forward bias, hence current flows across the load resistance RL. During negative half cycle and A is negative and B is positive and the diode is reverse bias, okay, and no current flows through the diode and no output will be obtained. So basically input and output we will compare. This is input and output. For the positive half cycle you are getting output only. For positive half cycle, output is there. Negative half cycle, no output, because the diode becomes a reverse bias. Positive half cycle, again output. Negative half cycle, no output. Okay. Suppose the frequency of this input is 100 volt. So the frequency of this also will be 100 volt. Because in a time period, the number of revolution or number of waves is frequency. So time period is 0 to t is the time period. So in this time period, there is only one wave. So 0 to t time period, how many waves are there? One wave. So that is why number of waves in a particular time is frequency. Number of waves per unit time per second is a frequency. So 100 hertz frequency, and here also output having 100 hertz frequency. So frequency of input and output remain same in case of the half wave rectifier. Okay, Hamza. So first you should take these screenshots. Then we will discuss the next topic. Hello, Hamza. Please take the screenshot.
Yeah. Yes, I.
Oh, Nida, you are there. Nida, have you understood the this characteristics? Okay. So please take this screenshot.
Done.
Done. Okay. Okay. So now take this screenshot, both of you. Okay. Take this screenshot. Okay. Take this screenshot. Okay. Now please take this screenshot. Okay. Okay, please take this screenshot. Okay. Now what is rectifier? This also you should take a screenshot. Okay. Hamza, done? Okay. Now half wave rectifier, please take this screenshot. Okay. Take this screenshot. Okay. Please take this screenshot. Okay. Hamza, taking screenshots or not?
Sir.
Okay. Okay, so half wave rectifier is there. Now we will discuss the full wave rectifier. So in case of the full wave rectifier, this is the primary winding, secondary winding, and primary winding is connected with the AC supply like this. Okay, positive half cycle, negative positive half cycle. N1 is the number of turn in the primary winding, N2 is the number of turn in the secondary winding. This is point A, this is point B. And here in this case, the load resistance is connected like this. This is diode 1 and this is diode 2. Okay. So during the positive half cycle, A is positive, suppose, and B is negative. So if A is positive, positive is connected to P side and negative is connected to N side. This is P side, this is N side. This is P side, this is N side. So this diode will be forward wise. This diode will be forward wise and this diode will be reverse wise. So this diode will conduct means current will flow through this diode means current through this circuit will flow and current will reach to the load resistance, and when the current will reach through the load resistance means we will get the output during this positive half cycle. Now during negative half cycle, see, this A becomes negative and this V becomes positive. This V becomes positive. So now what will happen? Negative is connected to P side and positive is connected to N side. So this is reverse bias and this will be forward bias. So if this will be reverse bias, so no current will flow through this circuit, or no current will flow through this diode, but this is forward bias. So the current will flow through this diode and the current will reach to the load resistance. Again, we will get the output. So during the negative half cycle and during the positive half cycle, for both the cycles, we will get the output. Hmm. So input positive half cycle, negative half cycle, positive half cycle, negative half cycle. So for the positive half cycle, we are getting output. For the negative half cycle, we are getting output. Okay. So now comparing the frequency. If the frequency of the input is 100, then the frequency of output will be 200. So this will be 0 to t time period. So in this will be here 0 to t time period. So in t time period, one wave is completing here. In t time period, two waves are completing. So frequency will be double. So frequency of output will become double of input. So theory you have to write by yourself in the exam. So what you will write during the positive half? I am telling you the theory or working how you will write. You will write that during the positive half cycle, D1 is forward wide, D2 is reverse wide. So if D1 is forward wide, then D1 will conduct and D2 will not conduct. Means through D1 the current will flow and the current will flow through the load resistance and we will get the output. Now for the negative half cycle, D1 is reverse bias, D2 is forward bias. Okay, D2 is forward bias. So in that case, only D2 will conduct and the current will flow through D2 to the across the RL and we will again get the output. So you will write that for both the cycle, for the positive half cycle and for the negative half cycle, we are getting the output here. Now another is the filter circuit. So basically what is the filter circuit? I am telling you why we are using filter circuit. This we are getting a DC current, but there is some component of AC, you can say. In this DC, there is some component of AC. We want this type of DC actually. We want this type of DC. This type of DC. We do not want pulsating DC. Okay. So for that, we will use the filter circuit. So now what is the filter circuit? The output obtained from rectifier is unidirectional but pulsating. Unidirectional means it is only in positive direction. No current is in the negative direction. Here is positive and negative. Here is only positive. Okay. So the output obtained from the rectifier is unidirectional but pulsating. Pulsating na, like this. To get pure DC, filter circuits are used. Filter Filter means, filter circuit means it will filter the AC component and it will give us the pure DC. So there is a type of filter uh, circuit, shunt capacitor filter. Shunt capacitor filter. Shunt capacitor filter means we will connect a capacitor in parallel with the load resistance. So this is a full wave rectifier here, and here you have connected a capacitor in parallel with load resistance. So now you will see what will happen. See what will happen here. Suppose we are getting some output here. Suppose here we are getting some output current, and this output current is containing AC component, DC component plus a sum of the AC component. Okay. Now we know that in case of the capacitor, the capacitive reactance is equal to 1 upon omega c, but the frequency of DC is equal to 0. So that is why capacitive reactance will become infinite for the DC. So it means the capacitor will block DC. In capacitor, the current cannot flow. In capacitor, the DC current cannot flow. Okay, DC current cannot flow. So in this capacitor, no DC current will flow. So means only AC current will flow in the capacitor. Whole of the AC current will flow in the capacitor and remaining DC current will flow through the load resistance, and the current that is flowing through the load resistance, it's our output. Now we are getting only DC. We are getting this type of output, pure DC. Okay. So the to filter AC circuit, component from the output obtained by rectifier to filter AC current, component from the output obtained by rectifier, we need to connect a capacitor in parallel with load resistance, and capacitor offer infinite resistance to DC, and pure DC will flow across the resistance. To filter AC current component from the output obtained by rectifier, okay, we need to connect a capacitor in parallel with load resistance and load resistance, and capacitor offer infinite resistance to DC, and pure DC will flows across the load resistance. Okay, so full wave rectifier. Hamza and Nida, both of you take the screenshot fast. Done, Hamza?
Yes, sir.
Okay, do this also. Just a minute. Now take the screenshot. Okay. Oh, Fawaz, you also there?
Yes, sir. Just now.
Okay, so take this screenshot. Done, Fawaz?
Yes, sir. Done.
Okay. So now please take this screenshot.
Yes, done, sir.
Okay. So this chapter is finished. And along with this, your syllabus is also finished. Okay. Fawaz, if you want to take the screenshot of from
Sir,
today's
that
class.
waveforms.
From
waveform of
waveform, na?
rectifier.
Oh, waveform. That's okay. This one.
Yes, sir.
Okay, you should take the screenshot from the starting because you have joined late. So I have started today's lecture from here. So you should take this screenshot from here.
Okay, sir. Yes, sir, done.
This is done. Okay.
Sir, done, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Okay.
Yes, okay.
Rectifier.
Yes, sir, done, sir.
Half wave rectifier.
Done, sir.
Okay, the working.
Yes, done, sir.
Okay. Input output. Waveform.
Yes, done, sir.
This one.
This I took full wave rectifier.
Took na? So basically here your level finished, and when will be your exam started? First I am asking to Fawaz.
Sir, in March physics.
No, I'm not talking about the physics. Means first of your exam.
First
exam.
February 24th, maybe.
Feb 24. And Nida, what about you? When will be your first exam? 24th Feb. I think it will be of English, huh?
Yes, sir.
And Hamza, yours also from 24th Feb. Oh, you are from. I think you have taken biology, engineering, graphic exam. So guys, I think this is our last class because your exams are coming, so you have to prepare for that also. And so what I can say that do the revision properly, and whatever I means whatever you have studied by me and by any other teacher, it's time to revise that. And okay.
Sir, you will give extra class?
Extra class for what?
For this physics by you.
For
by you.
I'm not understanding what you are saying.
Like any extra class for revision?
Oh, for revision, yeah, of course, that will.
Okay.
If you, but for that now you should join the class. Otherwise,
Sir, because of this exam.
Yeah, that is why I was saying that maybe you will not join. But there will be the class. There will be the class for the revision also, because we have notes, and whatever I teach you, and I have means I told you whatever the knowledge I have, okay, and whatever the type of teacher I am, I don't know I'm teaching good or bad, but just I am giving my best. I don't know.
Sir, it's good. Best.
Yeah. No, nobody is best in this world, but we should try our best. So that is the best. So basically, we have completed. Actually, Hamza is from the starting, taking the classes from the starting. So I have started my teaching from here, this topic, and today I have just finished here. This is the whole syllabus. Basically, from this year, na, from the electronics, you can say from the semiconductors, at least 40% syllabus is removed. Okay, so what we will do, today I will leave you early. Uh, so what we will do now, if we will have a next class or we will inform you. So we will revise. Okay, one by one we will revise and we will try to revise fast as possible. Okay, and I will give you the next on the in the next lecture the what I am going to do. I am telling you all of you that I will tell you the strategy. Means I will tell you how to attempt the questions or how to when you will in the examination hall, means how to write any answer. Okay, and in how in the during these days what you should do, or how now at that particular of time, means how you will prepare, means how you should continue your study, means okay, uh, in the next class that we will discuss, because the syllabus is finished, I think, and uh, mm, so this is the step. This is physics basically. Actually, in the 12th class physics, lot of branches are combined. So it is started from electrodynamics, then optics, then modern physics, then electronics. 4 5 things are there, and they are to these branches are totally different. This electronics is totally different. Modern physics is also different. Electrostatics, or you can say electromagnetism, that is also different. So the main thing in physics is just uh, try to understand, not just you should learn the formulas and you are attempting the question. Try to get the feel of physics. Okay. Always try to get the feel of the physics. I know that this is not the right time because few days are left. Okay, but when you will go for the higher study, to always try to understand the things. Okay, so in the next class, we will discuss the strategy and we will discuss how to solve the question, how to attempt the question paper, and one more thing we will discuss. Uh, we will try to revise also few topics. Okay, few important topics we will revise, and please join the next class. And next class may be of hardly of 45 minutes to 1 hour it can be, or it can be 45 to 1 hour, or depending upon the situation. So now your syllabus is finished, and so how your studies are going, Nida, right now? Hmm? Fawaz, how your studies are going?
Good, good.
Good. Okay. Hamza, how your studies are going?
I can say.
Okay. And Nida, what about you? It's going studying. Okay. So so now we will meet in the next class. Okay. If there will be the next class, we will meet in the next class and we will revise the topic and some few other things I will tell you in the next class. Okay.
Okay.
Now from my side, the syllabus is completed. Uh, and